Hello viewers, I am Kausalya. Today we are going to discuss about the problems under the topic resistors in parallel. So the first problem is in the circuit shown below, calculate the current in other resistors, the value of unknown resistance and the equivalent resistance across AB. So here when you look at this diagram carefully, totally this diagram has how many resistors? 1, 2, 3 and 4, right? And can you tell me how the resistors are connected? Either they are connected in series or they are connected in parallel. So you see all the, that is one end of all the resistors are connected to A and the other end of all the resistors are connected to B, right? So this connection is known as parallel connection, right? All the resistors are connected parallelly, right? And here you see there is an input current of 10 amps and 5 amps flows through this 6 ohm resistor. So the first question is we have to calculate the current in the other resistors, right? So when you look at this resistor, the resistance value is not given. So we can just leave this. And here the value of resistance is given. We need to calculate the value of current which flows through this 30 ohm resistor and 15 ohm resistor. So here the simple logic is, since all the resistors are connected in parallel, the voltage across all the resistors should be the same. Do you agree or not? That is, voltage across this 6 ohm resistor will be equal to voltage across this X ohm, and that is equal to voltage across this 30 ohm, and that is equal to voltage across this 15 ohm resistors. Right. So here is the hint. You see here the value of current is given and the value of resistor is also given. So how to calculate voltage? Voltage can be calculated by simply multiplying this I into R. Right. Once the value of voltage is known, the same voltage exists across this resistor and this resistor. Right. So first we are calculating the voltage across 6 ohm resistor. So that is 5 into 6, which is 30 volt. Right. The same 30 volt exists across this 30 ohm resistor as well as this 15 ohm resistor. Right. So that is what mentioned here. Now you see the voltage across this 30 ohm resistor is 30 volt and the value of the resistance is 30 ohm. Then what about the value of current? So again by Ohm's law, V is equal to IR. We know the value of V, we know the value of R. So we can calculate the value of I. So the value of I is 30 by 30, which is equal to 1 amps. Right. Now the next thing is current in 15 ohm resistor. Again the voltage across this 15 ohm resistor is also the same 30 volt. So again by using Ohm's law, we are calculating the current flowing through the 15 ohm resistor as 2 amps. Right. Now we need to calculate the current flowing through this X ohm resistor. Right. But here we don't know the value of X also. That is the resistance value also unknown. So first we are calculating the current which flows through this resistor. So 5 amps is already given and just now we have calculated the current which flows through this 30 ohm and this 15 ohm. Here the current flowing through this 30 ohm resistor, here it is 1 amps and here it is 2 amps. Right. Now can you guess what will be the current which flows through this resistor? You see totally 10 amps. Right. So here goes 5, here goes 1 and here goes 2. So you see the total current is 10. This 10 amps gets splitted into 5 and current flowing through this X resistor is Ix and this 1 plus 2. Right. So when you rearrange, finally the value of Ix is calculated as 2 amps here. Right. Am I making clear? That is the total current is 10 amps. This 10 amps gets splitted and flows into 4 resistors like this. The 5 amp is already given in the problem and 1 amps and 2 amps just now we had calculated. Right. So just substitute here and calculate the value of Ix. So now when you look back at this circuit, you see we know the value of current which flows through this Ix. It is nothing but 2 amps. And the voltage across this X ohm resistance is also again it is a 30 volt, that is 6 into 5. This 30 volt exists across all these resistors. So we know the value of voltage, we know the value of current, so we can calculate the value of resistance, right? Again by using Ohm's law, voltage across this resistor is given by V is equal to I into R. Here the value of resistance is X, right? Therefore, just substitute the value and the value of this X is calculated as 15 ohms here. Now the second part of the problem is done. The third one is we need to calculate the equivalent resistance across AB. That is, we need to calculate the total resistance here. So, as we already know, all these resistors are connected in parallel. So, when resistors are in parallel, how to calculate the total resistance? So total resistance is given by this formula, that is 1 by R. Since it is between the terminal AB, I had written it as AB, right? So total resistance is given by reciprocal of individual resistances added together. So 1 by 6 plus 1 by 15, 1 by 30 plus 1 by 15, right? So here when you take LCM, the LCM value is 30, right? So then just calculate the numerator values accordingly. And finally you see the value of 1 by RAB is 1 by 3. So the value of RAB is equal to 3 ohms, right? Or there is another method by which we can calculate the resistance. It is so simple. By Ohm's law, V is equal to IR, right? We know the total voltage as 30 volt and we know the total current as 10 amps. You see here the total voltage is 6 into 5, 30 volt here. And the current is 10 amps. So we know the value of voltage and current. So we can calculate the value of resistance, right? So here we know the voltage value, we know the current value, therefore the value of resistance is 3 ohms, right? You see, both the values are same. You can use any method to calculate the resistance. Okay, this is just like max. You can use any method. Only the thing is the procedure and step should be correct, right? Now we are proceeding with our second problem. Two resistors are connected in parallel and a voltage of 200 volt is given, right? The total current taken is 25 amps and power dissipated in one of the resistor. Okay, it is 1500 watts. What is the resistance of each element? So here again the thing is two resistor in parallel and voltage across the resistor is 200 volt. Total current is 25 amps and the power dissipated in one resistor is 1500 watts, right? So first let us draw the diagram. Two resistors in parallel and they are connected to a voltage source of 200 volt and the current flowing is 25 amps, right? And power dissipated in one resistor is 1500 watts here. We need to calculate the value of R1 and R2, right? So from the given datas, okay, these are all the available datas here. We need to calculate the resistance value. So here first we are considering the power. Okay, power is given by 1500 watts. We are assuming that the power dissipated in the resistor R1 as 1500, right? So just write down it, and power is given by the formula. It is given by V1 into I1, right? And again the current I1 can be written in terms of V and R, right? So it is V1 by R1. So here it is V1 square by R1, right? Since resistors are connected in parallel, you see voltage across this R1 is 200. Similarly, voltage across this R2 is also 200, right? So here the voltage across the first resistor is 200, right? So 200 square divided by power dissipated is 1500. So here the answer is 26.67 ohms. Okay, we had calculated R1. And now you see the supply voltage is 200 volt and the current flowing is 25 amps. It is directly given in the problem. When you substitute Ohm's law, the value of the total resistance R is given by V by I, which is 200 by 25, which is equal to 8 amps. Can you get? That is from the basic data given, voltage and current, we are calculating the total circuit resistance. Okay, the total resistance is 8 ohm. And here the value of R1 is 26.67. We need to calculate the value of R2. Right. So, here the two resistors are connected in parallel. Right. So, what is the formula to calculate the total resistance? It is given by R1 into R2 divided by R1 plus R2. The total resistance of the circuit is calculated by Ohm's law, that is 8 ohms. So just substitute it here. We know the value of R1, right? So again substitute this in the formula. Now we are going to rearrange and calculate the value of R2. You see, we are moving this part to the left hand side. Then we are going to multiply these terms by 8 here. Right. So again when you rearrange, the value of R2 is calculated as 11.427. Right. So R1 and R2 are calculated here. And again there is a shortcut method. So now I'll explain that too. You see, the value of V is given by I1 R1. Right. Therefore I1 is given by V by R1. Just now, that is the first step is we had calculated R1, right? So when you substitute the value of R1 here, we can calculate the I1. That is the current flowing through the first resistor. For example, you see, we are having two resistors, right? So the total current value we know it is given as 25 amps. Now I had calculated the current flowing through this resistor as 7.5 amps. So automatically we can calculate the current flowing through this second resistor, right? So 25 minus 7.5 gives the value of current that flows through this resistor R2. So it is 17.5 amps, right? So we know the value of current flowing through the resistor and we know the value of voltage across this resistor because voltage across the resistor is 200 volt. It is given directly in the problem. So with the help of this voltage and the current, we can calculate R2. Right? Again, it holds the same answer, 11.43 ohms. Right. So here again, this is just like mathematics. You can use any method to get the final answer. But the thing is the procedure and steps you use should be correct. Right. So here comes the end of this video. If you have any doubt, let me know in the comment section. Thank you.